Now the ROI extractor function has got its inputs as the row, which is each of the row of the CSV file which we have made, which is all the information about the bounding boxes and the other dimensions of the image, and the base path. This is the path till this name of the file. So that's the base path. So we first read the image, using the CV2-ImRead method. So the path we give, which is the base path, and then the file name. So each row's file name is given. And then we extract the bounding boxes from the row. Like we get the xmin, ymin, xmax, ymax. So you can see that those stuff here, xmin, ymin. So you get the bounding boxes coordinates from the Excel sheet, and then based on the bounding boxes coordinates, we crop the image. We crop it both the height wise and width wise. That is what is going on here. So BB1 is your the height wise minimum, and BB3 is your height wise maximum, and so on. And then what we do is we do the augmentation. So here we are doing here for the positive classes, which is the potholes. We would have different approaches for both the potholes and the negative classes, which is the images without potholes. So here it's got the defaulted value. We are giving it an extensive augmentation. So you're doing all this horizontal flip, vertical flip, rotation, etc. All the angles that we're giving. So the return value is all the ROIs, or are the ROIs. The next function is to extract the features using the hawk features. So we take the ROIs which we extracted, then we give to empty list, which is to collect the data. So your data here is the features which you extracted using hawk features, and labels for the positive class, which is your potholes, is 1, and the negative class, which is those images without potholes, is 0 or -1. So we go through each of these ROIs, each of the region of interest. So as you said, each image could have got multiple versions, by augmenting. So we go through each of those ROIs, extract the features using the hog feature function, which we've earlier defined, this function, giving all those parameters, and then we append the data. So once we have the features, so we have all those features using hog features, we append it to the data list, and the labels we append it as 1, so that's a positive class, and you return the data and the labels. Now let's look at the process for extracting the positive images. That is, we give the path, which is your base path plus your data path. Now this is where the complete data is. So this is your path, which we give here. See the same thing. So this is your path, and you define all those parameters: orientation, pixels per cell, sets per block, etc. And then you define these empty lists also, where we store the data and the labels. So we iterate through each of those row in that Excel sheet. So this is our CSV file, pothole_df is here, and iter rows iterates through each of those rows, and we get the rows and the ID, the index of this row. So this row contains all the information. All these, one row contains all this information about that particular row. So we give that row. So we are taking only the positive classes, which is the potholes. So if the class is potholes, then we extract the ROI. So we get the ROIs using the ROI extractor we saw, and we get the data and labels using the feature extractor. Feat extractor, you get the data and the labels. Let's run this these cells and then get all those features. Let's look at the number, how many labels we have. So we've got 310 labels. That means, if you remember, our original number of potholes which I had collected was around 21 or so. But using these different types of augmentation method, I've been able to augment it from around 20 to around 310 labels. So this is the strength of this augmentation method. Even if you have limited data, you try augmentations and then get more data sets. But you always have to be careful with the kind of augmentation method which you use. It's all based on the type of objects which you're going to detect. Now we'll see the methods for the negative classes also, which is normal, normal images. So I've got so many of them, around 21 of them, 20 of them, and I'll just show. These are the kind of images which I've collected. So here without any pothole. So a typical kind of road with vegetations, and so in fact this is just a representation of just a couple of them, but you need to get a distribution with what you actually find in roads, maybe with cars and so many vehicles, but without potholes. That's a negative class which you can get. Okay, so let's get into how to do that, using how to extract these things or these features and labels for the negative classes also. So here again you go through each of those road files. So this is each of those path of the road files, and then we go through each, read the images, see IM read, and now we use a special thing for augmentation here called extract patches 2D. Now what it does is, this extract patches does is, it just extracts from the complete image, it just extracts certain patches of 18 to 40, okay, of the various size. So this is using a special method called extract features 2D, which is there as part of your sklearn. So extract patches 2D. So that is what we are using. So this is another way of augmentation, because we are instead of taking because here in the negative classes we don't have bounding boxes and ROIs, but we're just taking patches of the negative classes on the same size, different patches. So we take maximum number of we are defining that we are taking 10, but you can define more number of patches also. But make sure that your ratio between your negative and positive classes is balanced. That's why I'm not taking too many of these patches. So for each of those patch, we are again doing an augmentation. So here I'm doing false for the extensive augmentation. That is, here you're doing only the horizontal flip, because a road horizontally it is okay, but if you do it vertically and other rotation etc., it would distort the whole images. And so we get the ROIs, and for each of these ROI we, as before, we extract the features, append the with the data with the features, and then labels is appended as -1. So the positive classes is +1 and the negative classes is, let's run this and then see how many labels we have. So we have now totally 730. So if you remember, the positive classes were around 310 and around 400, and now 420 negative classes also we've got. So for each of those so if you remember, if we had around 20 of these or 21 of these negative classes, which is been augmented into around 420. So this ratio between the negative and positive is also kind of balanced. We have 420 of negative classes and 310 of positive classes. So it's almost balanced. So always remember to kind of balance out your different thing. Now what we'll do is we will store these your data and your labels in a format called HDF file. So that is what we are doing here. So we define an output path for storing this, and then we create a database using this HPL file format in the output path. So W means you have to write it into this. We create a data set which is defined by DB create data set, which is, name is pothole features. So the total length is length of data, the total number of features now, so which will be 730, and length data 0. So length data 0 is your number of features which we've got, and a type float. So and then we store the data sets, or so that's the number of features. This is the first part is for the features, and you add a number +1 here, and this is to store the labels. Okay, so you're storing the data and the labels together in one data set. Okay, so let's so if you run this, you will get a db file, the h5py file created in the output path. So I've already done this before, so I'm not running this. You should run this cell, and then let's read that cell, read that read that the database, or which we have stored as h5 format. And let's look at the shape of this of the data. So we have 730 XMLs and 8209 data. Here, out of 8209, 8208 is the number of features which is extracted using hog features. Now, these 8208 is not a fixed number. It depends on the size of the window image which you have selected for feature extractions. Now, if you choose a different kind of window size, you will get a different type of or different number of features here. So since for this 8040, I'm getting a 8208. It might be different for you based on the window size which you select. And the last one, 8209th index, is your labels. So that's how the data is. Now, next we will get into building the classifiers. Now we have stored the data, both the positive and the negative classes. Now using that, we will build a classifier. We will build a classifier using SVMs. That's what we are going to see next. So as we end this post, let's recap all what we achieved in this post. So first, what we did was we were introduced to the labelImg, and using labelImg, we annotated the images, and then we saved those information to a CSV file. And in the next few videos, what we did was we extracted those information, the bounding box informations, and then build features using hog features extractions, and then we saved it into and finally we saved these hog features into an HTF5 format. Now in the subsequent post, we will use this information to build the classifier and the object detector. So I believe you have enjoyed this video, and if you have not subscribed to the video, please remember to subscribe to the YouTube channel and to the blog post. See you in the next post.